you also have to be able to write a balanced molecule. In other words, a molecule that has no charge, which means the pluses and the minuses are equal. So one of the things that you need to be sure you know, and this is something that you had in the memorized ions last semester, is what you're seeing on the board. So would you please take a moment now and copy that down? Yeah, the GP number that you see at the beginning of the first row refers to group number. Now that you have that down, what we want to do is figure out how in the world are we going to write the molecule from the atoms. The atoms of barium and chlorine are written at the top. Now what I'm going to do is write them again as ions. Okay, this is the ion that these atoms will form. Now if we go by this, barium is numbered 56 on the periodic chart. What column is he in? Come on. He's in column 2. So what's his charge? 2 plus. Okay. Chloride is going to be in, he's number 17. What column is he in? Huh? Okay, he's going to be in column 7. So column 7 is what charge? As an ion? 1 minus. Okay. Now we're going to write the molecule. So when we're writing the molecule, we're going to have just barium and chlorine and their subscripts. So who can tell me what the subscripts are going to be on barium and chloride? Can anybody figure that out? It's been a while. Okay, Genesis, go for it. 1 and 2, you're absolutely right. So, how did he do that? Tell us how you did it. The Crissy Crossy. Yeah, we did the old Crissy Crossy trick. We took this guy and put it down for the subscript for this guy. Then we took this guy and put it down for the subscript for this guy. Now, why didn't I write the 1 on the barium? Because it's a 1, and because it's a 1, it doesn't get written. Yeah. So it's just BaCl2. All right? Is that pretty clear? Okay, let's go ahead and clear that out, and let's look now over at this little thing. What is there? Oh well, hopefully I didn't just throw that away. So we use Crissy Crossy, gets us the correct subscript for each of the atoms in the molecule. And the other thing that's important, what's the other important thing about that molecule? What does the overall charge on the molecule have to be? Okay, if I have one of these guys with a 2 plus, okay, so this charge right here became, with absolute value, a 2. This charge here became an absolute value of 1, which we don't write. Now, the thing that we have to have is a net zero charge. So how many bariums do we have? How many bariums? 1. So 1 barium times its charge. What's the charge on barium? What's the charge on barium? It's 2. Okay, so this is equal to 2 plus. And what's charge on how many chlorides do I have? 2. So 2 chlorides times its charge, which is 1 minus, gives us a 2 minus. When we add those together, what do we get? Net zero. Okay, that's what we have to get with every molecule. And when you guys are doing the word equations, and then you're doing the, the skeleton equation, And then when we balance the skeleton equation, we call it a balanced equation. Okay? So as you're doing that process, there's, very first thing you need to know is that the Crissy Crossy gets the correct subscripts. When we get the correct subscripts, these numbers will come out equal to each other, the 2 plus and the 2 minus. Okay? So starting with our word equation, which is right down here, it's part of the do now, we have lithium chromate. So lithium chromate is the first guy we got to work with. Now lithium is in what column on the periodic chart? He is atomic number 3. 1. Okay, so he's going to have a 1 plus. All right, that's lithium. Chromate. What's the formula for chromate? Come on, look on your memorized ions. Come on, look on your memorized ions. If you don't have one, get one. Okay, so when we look on that memorized ions chart, in that box in the middle, we're going to see this CrO4, and it's going to have a 2 minus charge. So, how are we going to write lithium chromate? How many lithiums do we need? How many lithiums do we need? 2, okay? And how many chromates do we need? That's the Crissy Crossy. That's what we just talked about. Now, is that just one chromate? Is it? Why do you think it is? How many chromates do you think I've written? What is CrO4? It's one chromate. So how many chromates do I have? How many chromates? 1. Yeah. There's 4 oxygens in the chromate ion. Okay, you got to be careful of that stuff. So it's Li2CrO4. Okay, so we've just taken care of this guy. Now let's do the barium chloride. Barium is number 56. So what's his charge? Come on, come on. Barium, number 56, what's the charge? He's a group 2 dude, so he's a 2 plus. Okay? And who is barium with? Chloride, and chloride is atomic element number 17. What charge does he have? Come on, what's his charge? 1 minus, because he's in column 17. Okay, you all wrote that chart down, didn't you? That I gave you? Okay, so we have barium and chloride. How many bariums am I going to have? That tells you your barium, so there's no subscript. Chloride. How many of these do I have? I look to the barium. Okay, and the barium tells me that I'm going to have 2 chlorides. And so we've put together the left side of our equation. Barium chloride. Okay, now we're going to do lithium chloride. We already know the charges, don't we? So what's lithium? We already see it up there. Okay, there's a 1 plus. And so we've got a lithium, and we're going to have chloride, which is a 1 minus. So how many of each do I have? 1. Okay, no subscripts. Ta-da! This is review. We did do this last semester. Okay, so let's go back now to barium chromate. What's the charge on barium? 2. Chromate, 2 minus. So how many of each do I need? Ah, somebody said 2. Naughty, naughty. Oh, yeah. Okay. Here's where we get into something that we got to understand. Let's say that the balancing of some equation. I'm not going to tell you which one it is right now, but let's just say the balancing of the equation is 2, 5, 3. Okay? And on a test, you see this as one of the answers. But you're also possibly going to see 4, 10, 6. Is that the same ratio? It is. That's the wrong answer. How can I get these numbers from these numbers? Divide by 2. This could be another one of your answers. Is that the same ratio? It is the same ratio. This time I divide by 4. 8 divided by 4 is 2. So the 8, there we go. 8 divided by 4 gives you 2. 20 divided by 4 gives you 5. And 12 divided by 4 gives you 3. So, which one are you going to circle? The first one. Okay? So it's important for you to understand that we have to use the smallest possible ratio. So with barium chloride, or barium chromate winds up being like this. Okay? So this winds up, and I shouldn't have put that out yet, but let's go ahead and balance this guy. How many lithiums on the left? 2. 2. Okay? 2 because of the 2. Oops. The 2 right here. How many lithiums on the right? 1. So what do I do? What do I do? What number do I need out front? 2. Okay, so 2 times 1 is 2 lithiums. 2 times 1 is 2 chlorides. Okay. Chromates. How many on the left? 1. Oh, nobody said 4. Very good. Okay. So 1 chromate on the left. How many chromates on the right? 1. Good. Bariums on the left. 1. Bariums on the right? 1. Ah, nothing to do, huh? Chlorides on the left? 2. Chlorides on the right? 2. Because of the 2 here, 2 times 1 is 2. Okay? So are we starting to make a little more sense of this? That's what I was wanting you to do in the do now. So this guy, let's do some ratios on him. Did you get him? No. Okay, that's all right. Let's do him down here. So a 1, whoops, 1, 1, 2, 1. 1, 1, 2, 1. How else could that ratio look at on a test? 2, 2, 4, 2. That would be the wrong answer. Okay, that's called a sucker play. Okay, what else could I have? I could have 4, 4, 8, 2. And what if I multiplied this guy by 3? 3, 3. 3 times 2. 6 and 3. Multiply everything by 3. That would be another sucker play. Okay? They're all the same ratio. But these guys are good over here, and these guys are good over here. They're all correctly balanced, but only one is the correct answer, and that's the first one. Okay? This. Ooh, doesn't that look nice? So looking at your homework from last night, This is one that gave a lot of people a lot of trouble. How many of you had problems on this one? Come on, be honest. Okay. I'm going to show you how to fix the problem. You'll either balance it more easily or it will make it possible for you to balance. And there's one thing that you don't know about that, well, you probably don't know about, and that is that water doesn't have to be written H2O. HOH. Now, what does this look like? No. That's not what I meant. Just a minute. So if you look at the O and the H, what ion does that look like? Look on your memorized ions. Come on, look at it. Starts with an H. Hydroxide. Okay. Is hydroxide on the left side? Do you see hydroxide on the left side of the equation? Ah, there it is. Okay. So we can balance using hydroxide instead of oxygen and hydrogen. But remember, when you do that, that this H is no longer hydrogen. It's part of the hydroxide ion. Okay? So, let's look at, what is this guy? PO4. What's his name? Phosphate. Is he on the right side? He is. Oh, nice. That means instead of balancing for phosphorus and oxygen, I'm going to balance for the phosphate ion. This really simplifies your job. So let's go ahead and start using that concept. Watch what we do. We'll start with calcium. So calcium on the left, 1. Rebecca, tune in. Calcium on the right, 3. 3, because of that 3 there. Okay, so how do I fix that? How do I balance that? 3. Okay, did that balance my hydroxides? How many hydroxides do I have now that I have a coefficient of 3 here?
6.
Good. 3 times 2, 6 hydroxides. What do I put here to get 6 hydroxides?
No, 6.
6. Ah. You see it now? Because you want to be looking for this guy. All right? That's what you want to do. And if it makes it easier, just cover that thing and don't be confused. Okay? Now, we're partway there. How many hydrogens that are not part of hydroxide? Here. No, here. 3. Okay. Now, that means that this guy doesn't quite work yet. Let's go on. Phosphates. How many on the left? Don't get trapped by that. That 4 means 4 oxygens in the phosphate ion. Okay? Isn't that easy to get tripped on? Yeah. Okay, so how many phosphates over here? 2. Okay, what do I need here? 2. Now I have 2 phosphates on the left because of this. I have 2 phosphates on the right because of this. And I dare say we are balanced. Let's check it out. Okay, yeah, we'll put a 1 here after we check it out, though. Calcium's on the left. How many?
3.
On the right?
3.
Good. Hydroxide's on the left. 3 times 2, 6. Hydroxide's up here. 6 because of this. Good. Hydrogen's on the left. 6. 3 times 2. And how many hydrogens here? 6. Okay, we're done. Phosphate. 2 phosphates. 2 phosphates. So now we can go ahead and put our 1 here. Yeah, good? Good. Yeah, I just added a page. I didn't want to do that. Those of you at home, you want to copy this down. We're going to need it for tomorrow's class. So let's get this copied right now, unless you want to come up and use your phone and take a picture. All right, for those of you at home, you need this full screen. So go ahead and copy this down and have it ready for class tomorrow. Don't come in without it. This is something that came up just as people were leaving, but on this page, what you're seeing right here with the brackets means that you can't rely on these as always being the charge. That's all. But it's a good guess that the guys in column 4, like carbon, okay, carbon and silicon and germanium, they're probably going to form a 4+. Okay, and the guys in column 5, which would be like nitrogen, phosphorus, and arsenic, okay, those guys will normally form a 3, but you can't depend on it. These guys, you can depend on. Okay, that's it.